This topic is not in the monthly assessment test. You will have only the topics which you have studied. The moment or the turning effect of the force. How we define the term moment or a turning effect? When we apply a force and we rotate an object. For example, here's an object and this is a point of rotation, which is also known as the pivot. And we apply a force, an upward force. So when we apply an upward force, what will happen? Because of this force, the object will move, but this motion will be a rotation. So whenever the force causes a rotation of an object, what we call this effect, we call that as moment. So moment is refers to turning effect of the force. And the moment is a vector quantity. When we say it's a vector quantity, means it has direction. A moment can be a clockwise or it can be anti-clockwise. If the turning effect is a clock, like in this case, we apply a force, which direction the object is rotating, clockwise or anti-clockwise? What is the direction of the rotation of this object? So this object is rotating anti-clockwise. And how we can work out, yeah, that's right, the anti-clockwise turning effect. And how we can work out the moment or calculate the moment. The moment is actually a product of force and the distance. So, but what distance we take? We always take the perpendicular distance from the point of rotation. So if we apply a force of 10 Newton at a distance of 2 meters, so what is the turning effect of this? It will be 10 multiplied by 2, which is 20 Newton meter. And 20 Newton meter, because it is a vector quantity, clockwise and anti-clockwise are also refers to direction. So it is anti-clockwise. And because it's a vector quantity, so if the two moments are acting in the same direction, we will add. And if two moments are acting in opposite direction, we will subtract. So if we apply a force on the object, the force F is applied. And here is a pivot, a point of rotation. And we have different distances given in the question. So which distance we should use to calculate the turning effect? A, B, C, or D? Which distance I should use to calculate the turning effect of this force? So we should always use the perpendicular distance, the distance which is perpendicular. Which distance is perpendicular from point of rotation? B is making 90 degree. A is not making 90 degree. B is not making 90 degree. C is making 90 degree. And D is, again, it's less than 90 if we draw. So C is the right answer. So whenever we want to calculate a moment or turning effect, we always need the perpendicular distance to calculate. If there's an object and weight of the object is acting downward, and we have the dimensions, we have this length is 2 meters, this length is 3 meters, and this length is, well, let's take 4 and 3. So this is example 3 meters, this one is 4 meters, and this one is 5 meters. And we have a point of rotation or a pivot here. Which distance I should take to calculate the turning effect? What should be the distance I should take to calculate the turning effect of the weight or due to weight? 3, 4, this distance is 5, this total length is 5, okay? I should take 3, 4, or 5. 3, 4, 5 with distance. So the correct answer is 1.5. 3 is this total length. This I drew at the weight is there acting at the center. So half of the length will be 1.5. So if I want to calculate a turning effect, it's not like I take the total length. I will only take the length, the perpendicular distance, the 90-degree distance from the point of rotation till the force. So I don't bother about maybe that length is 3 meters, 30 meters, 300 meters, but I only need the length till the point of action of the force till the pivot. Is it clear, this example? For example, an object is there. Yes, sure, I will repeat. Look, in this question, in this example, I gave different lengths. I gave a length of a 3 meter is there, a length of 4 meter, and the length of 5 meter. A force or a weight is acting downward. And the question is calculate the turning effect or the moment. So how we calculate a turning effect or the moment? Moment is a product of force and distance. The distance is a perpendicular distance. So this is a force acting. And this distance is actually a distance between the pivot and the point of action, the perpendicular distance between the pivot and the point of action of the force. So the perpendicular, because the total length was 3, so the half of the length will be 1.5. So when I'm calculating a turning effect of this force, so it will be W multiplied by 1.5. If we have another object and we have the pivot, and the weight is acting downward. An example, there's a force F here. We have the distances, say this is 2 meters and this one is 8 meters. Which distance I should use to calculate the turning effect of the weight? The turning effect of the weight, how I can calculate that? So how I can calculate the turning effect of the weight? We need the perpendicular distance. So we draw a line from the point of rotation, the pivot, till the force. So this is the distance. So if the total length was 2, if the total length is 2, we just draw the line from the pivot till the force. So if the total length is 2, so this length will be equals to 1. If I need the turning effect of this force, which length I should use? What should be the length to calculate the turning effect? So if this is 8 meter, this side will also be 8 meters. So when we draw a line which is 90 degree or perpendicular to the force, so this is a line which is 90 degree or perpendicular to the force. So what will be the distance we should use? We should use 8 meters. So to calculate a turning effect of the weight, it will be W multiplied by 1. To calculate the turning effect of the force F, it will be F into 8. How do we know? How do I know weight goes? How to understand the concept of the turning effect? So what you have to do, you hold the object, like take a paper and hold it from this end, the pivot. And just open, like keep this paper in your fingertips, between your fingertips, and hold it from this point. And gently decrease the force. So which direction you will find the paper will turn? It will turn in this way. So which direction it causing a turning effect? It means it is causing a turning effect in clockwise direction. Where if the force F is there applied, which direction it cause a moment? It cause a moment in anti-clockwise direction. So moment is a turning effect of the force. So less than a minute left. I'll share another link and we'll continue this topic. Join from another link.